in today's lesson, we're going to look at chemical symbols. Now, the chemical symbols, I'm sure by now you are aware that for you to answer any questions in chemistry, you need to have a periodic table. So, from the periodic table, we have symbols in form of letters. So, I'm sure you observe that we don't usually write a word in full. For example, we say hydrogen, always written like that. No, we use chemical symbols. So for example, hydrogen is represented by the letter capital H. So apart from that, you'll find that we also have calcium. Calcium is represented by capital C and small a there. So now, if someone says, for example, copper, by now, most people are now maybe accustomed, just looking at it, since hydrogen is capital H, calcium, they're just two letters there, then eventually copper then will be CO. It doesn't work like that. We have specific set of letters which have been given on the periodic table. So if we look at copper, we use capital C and small u there. So if we were to write, for example, let's say cobalt, that will be capital C and small o. So you're going to note that whenever you're writing these chemical symbols, always the first letter is a capital letter followed by a small letter. So if you are able to write the chemical symbols there, this should also introduce you to basic structures of the atomic representations of these various elements on the periodic table. So the first task which should always come in mind, whenever a chemical symbol is presented, it will come and form either a molecule, it will form a compound, or it will be used to represent ions. So it's very important to note that the way the chemical symbols are presented on the periodic table, for example, if we look at helium, it is capital H, small e, and you will observe a number written on top there and another number written down there in that box there. So these numbers which are given, the 2 there and the 4 there, have meaning. So if you look at the number which is given on top there, which is the 4 there, this is representing the relative atomic mass, and then the number which is given down there is representing the proton number. Now, I'm sure you can note that there are new terms which have been introduced there. We are talking about a relative atomic mass there, and then we also have the proton number there. Now, you can only understand what this proton number is if we go back to the basic structure of an atom. So all these elements which are displayed on the periodic table there can be drawn in form of atoms, and that is what we're going to do. So if we draw the basic structure of an atom, we're going to observe that these atoms are known as the basic blocks of matter. So first of all, we have the central part of that atom, which we call the nucleus, and then around that nucleus we have what are known as shells there. So if this is the nucleus there, the nucleus contains 2 fundamental particles, that is the protons and the neutrons. And then I was saying that this nucleus is surrounded by the shells, or the shells there. So this shell that we have there is going to have also what are known as electrons there. So first of all, I was saying that earlier on, when we have that written, let's say we have helium there, and then we said we have 4 there, and then we have 2 down there. This number which is there is representing the number of protons there. So now, you need to know that every atom has protons, it has electrons, and the neutrons. So we can even come up with a very simple analogy to always help us remember. Others will simply say pen. To simply say proton, electron, and neutron there. So these have got specific charges. We have the protons, which are positively charged, the electrons, which are negatively charged, and then we also have the neutrons, which have no charge or 0 there. So in this setup, the number of protons is always equal to the number of electrons there. So if we said plus 2 minus 2, what are we going to get? We're going to get a 0. And that's why we even say that all atoms are neutral, or they don't have any charge there. It's because of the differences in the charges on the proton and the electron there. So once you know that, this is the atomic structure there. The atomic structure, in some cases, the electrons are represented using dots. So in some cases you see a dot there, it's also representing the electron there. And then in some cases they'll use crosses like that. So you need to know that in most cases, once that is done, we are now going to draw the atomic structure of the particular element we want to look at. So in this case, let us look at the very same helium we were looking at. So if we look at helium there, we said that all atoms have got a nucleus. So we'll say He there in the nucleus to represent this particular atom there. And then around it, we said that it has what? It has shells. So initially we said that this helium has 4 there and then 2 there. This 2 which we have there, which we are saying that it is the proton number, we need to know that when we are writing the atomic structure, we should show the electrons there. And since we said that protons are always equal to electrons there, so in this case, for helium, we have 2 electrons. So on the shell there, we are going to write our electrons there. So you can choose, if you want, you can use the dot. If you want, you can use the cross or the small letter E there. So in this case, we can use crosses there. So we need to know that we only get the number of electrons for a particular atom from the number which they will give us on that particular element which is displayed on the periodic table at the bottom there, which is the proton or atomic number. Is that okay? So once that has been done, you should understand that this number which is given there is going to guide you to find the number of electrons. But apart from that, there are also other rules which we should also consider, such as the maximum number of electrons that the each shell should have. So in the first place, you need to know that this innermost shell, the maximum number of electrons it can hold is 2. So if, for example, we looked at hydrogen, if it's drawn like that, we know that hydrogen only has 1 proton, meaning that it has a single electron. So its atomic structure will be drawn like that. So the symbols which are given on the periodic table there, and those numbers which are given there, the relative atomic mass and the proton number, are a guide which we are going to use to writing the atomic structure of the respective atom there. So now, once we have done that, let us try to look at, let's say, for example, sodium. Okay, so if we look at sodium, if you use the principle of the first letters to represent the chemical symbol, you get it wrong because you think it will be so. But in the actual sense, on the periodic table, you get it as it is written. We have Na there. And then from that, you're going to note that we have a 23 written there, and then we have 11 written down there. So I was saying that the number which is written down there is representing the proton number, of course, which is the same as the number of electrons in that particular atom. So in this case, we need to know that the maximum number of electrons we're going to get will be 11 when we draw that structure. So we can say sodium Na, following the same principle, always the first letter being a capital letter and then a small letter. This is the nucleus. And then once that is done, we have a shell there. Like we said, the maximum number of electrons that we're going to get there should be 2 in the innermost shell. So from the 11 that we have, if we remove 2, what are we remaining with? We're remaining with 9, isn't it? So we write another shell there. But it doesn't mean that since we have the remaining 9, we just have to put them there. No. We should also remember that the second shell is also supposed to have a maximum of 8 electrons there. So if I write that, and then eventually I've used 10, and the number that we have there is 11. So it means that we are remaining now with 1 electron there. So it will be in its shell there. So now there are certain things that you need to know. Once you have drawn this, which is the atomic structure of sodium, the electron which is in the outermost shell there translates to the group to which it belongs. So if you look at sodium, it has 1 electron in the outermost shell there. And if you look at the periodic table, there are numbers which are given in Roman numerals there. You will see that it is belonging to group 1 where you have 1 there. It will have 1 electron there. And again, that is its group number. And then if you try to count, if you look at the periodic table, we have horizontal rows which are drawn there. If you count the number of shells, we have this is 1, and then this is 1, we have 2, and we have 3. So it means that it will be in what is known as period 3 there. So the number of shells is always equal to the period there. And then the number of electrons also in the outermost shell is also equal to the group where it belongs. And that is why it is very important for you to know the chemical symbols there, and then even the notations or the numbers which support those given symbols there. And then apart from that, always remember, in some cases, the periodic tables may be drawn differently. Always refer to the key which is going to be given to you there. Where in most cases they will use X and then they will say A and B there, and then they will even state if A is the relative atomic mass, and then we have B there, which will be the proton number there. So always remember to consider that. Now, apart from that, from this same symbol which is given there and the numbers which support that, with the numbers which support that, you're going to note that the number which is given there, which is 23, if you subtract 11 from this 23, if we say 23 minus 11, this is going to give us what? What is it giving us? It will give us 12. So this 12, which it is giving us there, is now representing the number of neutrons. So thank you. We'll come and continue from there.